Section 6.3 in our books is titled Prove Triangle Similar by AA, Angle, Angle. So we've done a lot of angle, side, side type stuff, all to prove congruence. Now we're going to take a look at how we can prove that triangles are similar. So quick review of ways that we learned to prove that two triangles are congruent to one another. We have side, side, side. Side, side, side will prove that two triangles are congruent if we show that we have three sets of corresponding sides. We had side, angle, side. Two sets of congruent sides and a congruent angle in between the congruent sides. We had angle, side, angle. Two corresponding congruent angles, and the side between them was congruent. We had angle, angle, side. Two congruent angles, and then a side that's not between them could be congruent. That proves that we have two congruent triangles. And then also one special one for right triangles is if we have congruent hypotenuses and one of the legs are congruent. That will also prove that the two triangles are congruent. And then we also briefly talked about ways that you might think could prove congruence, but did not. One is if we had three congruent angles does not prove congruent triangles. We could have two triangles that are exactly the same shape, where these angles are the same, and these angles are the same, and these angles are the same. But they are not congruent triangles because they're different sizes. Side, side angle also did not work. So two congruent sides. If the angle in between them was congruent, we had congruent triangles. But if it's another angle that's not between those two, those are not necessarily congruent triangles. Today, instead of looking at congruence, we're going to be looking at similarity. So notice in this case, when we had angle, 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 well, if we have corresponding angles that are congruent, then those are similar. They're the same shape, even if they are not the same size. So this is called the angle-angle similarity postulate. Notice we just talked through, okay, angle, angle, angle. It's actually even easier than that because if I know these two are congruent and I know these two are congruent and I know all of them add up to 180, we don't even necessarily need to know that these are congruent. They just have to be because the first two are. So all that is necessary in order to prove similarity is that we have two sets of corresponding angles that are congruent. So the angle-angle similarity postulate says if two angles of one triangle are congruent to two angles of another triangle, then we know the two triangles are similar. We have two sets of congruent angles. The two triangles must be similar. So example 1 here asks us to show that those two triangles are similar to one another. And we are asked to write a similarity statement. We know that angle CFD is equal to 90 degrees. It's showing us that that is a right angle. We know this is a right angle here as well, because we have a straight angle right here. So these two must add up to 180. If this one's 90, that one also has to be 90. So CFD, angle DFE, that's not a D, is also 90 degrees. So these two are congruent. We also know that these three angles need to add up to 180 degrees. So we can say 90 plus 58 plus, let's call that one X, is 180. 148 plus X is 180. So X is 32 degrees. Angle EDF is 32 degrees. It tells us right here that DCF is 32 degrees. Notice we have two sets of congruent angles. We could prove that the third set of angles is also congruent. We don't need to, though. Angle similarity postulate says that we just need two sets of similar angles, not similar angles, congruent angles in order to have similar triangles. So show that two triangles are similar. We could say by the angle similarity postulate. It also tells us to write the similarity statement. So I'm going to say CFD, I'm going to call that one triangle CFD is similar to, and we need to go in the same order, just like we did with congruence. We need to make sure that the corresponding angles match up. So CFD, I started at the 32-degree angle, that's right here. And then I went to the 90. And then I go to the 58-degree angle, DFE. And I forgot my triangle symbol. Triangle CFD is similar to triangle DFE. You could also say FDC is similar to FED, or FCD is similar to FDE. There's lots of ways that you could state it, but we need to make sure that vertex C on this triangle corresponds with vertex D on this triangle. Notice they're both 32 degrees. Example 2, we are given this figure. Looks like we have two triangles, ACE, and we have BCD as well. And we are asked to show that those two triangles are similar. So we want to show ACE is similar to triangle BCD. That's what we're trying to prove. In order to show similarity, we just need to show that we have two sets of congruent angles. Notice as we go here, down, and up, start here, go this way, those those two triangles. They appear to be the same shape, just different sizes. Notice both times we start at A, go to C, and then E, B, C, D. This angle corresponds with itself. We know angle C is congruent to angle C. Angle C is congruent to angle. If we were doing a two-column proof, we would state that that's the reflexive property of equality. We need to show that we have another set of corresponding angles. Notice we have these two lines that's showing that those are parallel. If those are parallel and we have a transversal, we have another segment that cuts through those parallel lines. Remember, we had lots of sets of congruent angles, including this one here and this one here. Angle EAC is congruent to angle DBC. If we needed to give a reason, maybe we had to do a two-column proof, we would state that corresponding angles in parallel lines are congruent. This one, yeah, we're going to go ahead and write them out. Reflexive property of equality or congruence. We have two sets of congruent angles. That's enough to prove that our triangles are similar. Triangle ACE is similar to triangle BCD. Reason? Angle-angle similarity postulate. One more example, and it's a story problem here. It's got a figure as well. It says that Ria's boat has come untied and floated away on the lake. She's standing right here at the top of the cliff. The cliff is 10 meters above the water in the lake. She smartly stands a little bit back from the ledge, 3 meters back from the edge of the cliff. And she can visually align the top of the cliff right here, point B, with the water at the back of her boat. So basically, when she sees here, the edge of this cliff lines up exactly with the back of her boat here. And it tells us that her eye level is 1.5 meters off the ground. She's 1.5 meters tall. We need to know how far out is the boat, approximately how far out from the cliff is Ria's boat. We're looking for this distance here. In order to do that, we want to set up similar triangles. We should probably talk through why we have similar triangles. We've got a couple triangles here. Let's work with these two. We've got this triangle here. My lines are not straight at all. And then we also have this triangle here from her eye all the way down to the boat to point F right there. Those sure look like similar triangles. We can prove that they are by stating that this angle here is reflexive with itself. That's congruent. We also know that we have a 90-degree angle right here and a 90-degree angle right here. So we have two sets of corresponding angles. We do have similar triangles, which means we can set up a proportion in order to solve for this distance. That's what we're trying to find, is how far from this edge right here is this boat. When we do that, we want to take two corresponding sides that we know. We know this side here is 10, and we want to write a proportion. So I'm putting the smaller triangle on the top. That side's 10 over this side here, the corresponding side with that. Well, if this is 10, these are parallel. So this is 10 right here, plus that 1.5. This side's 11.5. Is equal to this side right here, which is y, over the corresponding side, which is this bigger one. Notice that side is y plus 3 more. And here's our proportion. To solve a proportion, we cross multiply. We have 11.5y is equal to 10 times y plus 3. We can distribute our 10. Subtract 10y. And divide both sides by 1.5. And you could go with a calculator here. That way would work. And another way, if you don't, whoops, it's not what I meant to do. Another way, if you don't necessarily want to work with the decimals, and I don't love working with the decimals either, is we can multiply here by something that's going to clear our decimal out, like maybe 2, or a lot of times we use 10 to move the decimal point over. I'm going to do 2 just to keep the number smaller. 1.5 times 2, I know that's 3, and this is 60. Divide by 3. Either way, you get y is 20. Probably should include units there, 20 meters. Make sure we answer the question, how far out from the cliff is Ria's boat? It's not real clear exactly what it wants here. I think it's asking you to call this the edge of the cliff and to find that distance, which is indeed 20 meters. If we're considering this here, the edge of the cliff, how far out from the cliff? Yeah, I guess this is the cliff, so 20 meters. If it wanted this distance, I'd go 20 plus the 3 right here and be 23. 20 meters is correct.